Hello, beautiful people and future me. So we will type today. Let's begin with it. All right. So we have something I don't expect good result. 11:35. It's not the worst. And the next thing we will do is the execute program. Let's see, 90, 100, 100, cool. Some number type error, has email, can be admin. Type user has email and can be admin. Yeah. Return email, extract. Okay, so this will be Amir as example. Come. Maybe it's number or undefined. If it's true, it will be 5, otherwise. Okay, so it is 5. It is number, and we are trying assigning the maybe number to a thing. So this will be type error, I believe. What are you doing? And it is. So we have a type user with a name only, function name or length. It takes user or array. If it's array, it will do the user's length and else user's name or length. So this will be Amir. There we go. Type error. Strings, a string. This will be undefined. That is string 11. Type started course. True. Unstarted course false. The course could be started or unstarted, and we have a course which has a false. And okay, so this is type error. Type username of string, function name or length. So that takes user or users, user or array. If it is array, it will return length. If it's not, it will return the name. So name or length, and we are putting in array, so the result will be 2. Has email, email string, can be admin. There's a unifying type, conclusion, intersection type, something like that. Email, Amir, true, extract admin, has email admin, but the has email is only of email, so this is type error. Number maybe, undefined. Type started course, true, last interaction date, unstarted, started false. Course is union type. Course start true, 2000. Course last interaction date, so this will be 2000. Number may be number, true, it is 5. So n is a number may be, if it's undefined, n is 0 or 5, so this will be 5. Let n number, and we trying to assign it to a string, so it is type error. Number undefined, that is null, and that null number cannot be null, can it? I'll try type error, yep. Counts numbers, numbers prop, this will be undefined. Yep. You have his email, that got email string. What else? String type. Type can be, there's a union admin user that is missing the field, so that is type error. Started curves, true, interaction date, when it's false, that's unstarted. Doesn't have the other field, curves, false, type error. At 1, take number, outputs number, return number plus true, error. Some number is 2, and I did the review. There's another review. Let's do it. Type error, syntax error. Okay, constant string for line, that is type error. For line, that is a 4. Ah, dang it! Typo. Okay. Const add. Add 1 number, the x number, size 3. My string type will be string. String hello, so s2 will be hello. Function double, takes number, outputs number, returns double, anything, so this type error, number, 1232 string, this type error, and this one is type error. No, it isn't, so it will be 11, I think. Okay. My string type string. String type this is type error, that was a number. Now take second chance. So this will be the typo I did. So this is 4. And this one will be 11. And I finish. Parse null over string. Go, 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 go. Passing tests. So write a function that returns a string or undefined. A type, is that a union type? String undefined into a number. Oh no, so this is the input. Okay, and this is a number. The argument, if the argument is undefined, the function should return undefined. If the argument was a string containing a valid number, it should return that number. If the argument was string without a number, it should return undefined. Okay, you want to use built-in function parse int and is not a number. Okay. So first of all, if it's undefined, it should get undefined. So number undefined. Okay. So if input, that one will be string or undefined. If input equals undefined, return input. Okay, let's run it. And type error. Not all code paths return a value. Okay, so I'll do return input in here as well. I'll run it. Okay. if what was the SNANN input without the number it should return undefined. Okay, undefined. Maybe here. Let's say undefined and else will be return that was parseInt and input like so. So will this one work? Okay, type our argument type string is not assignable to type number. String is not assignable to type number. Cannot find type. Yeah, it might be not. Oh my god. Okay, this one runs. Undefined by that one. Okay. What about this one? Okay, so the first one passes, and this one is the right thing. Okay, good. So now we will parse the string. Maybe parse string. Or maybe I can do the not a number. So if is not an input return that find. Okay, type error. Argument type string is not accessible to parameter. It takes number. Okay. So do parse int. Like so. Okay, and something is failing. So we are returning 1, and we want parse int input return here. Okay, and that pass. That is good. That is good. Very well. Oh, but I don't know about Okay, I'm thinking of maybe a better way. No, this is okay. Okay, shared fields. Let's go. This is the shared fields lesson. Sometimes we want discriminated union with a field shared in both classes. Discriminate the union with field shared in both cases. For example, started course and unstarted course both have names we could use to duplicate the name field. Started course name, started that name, okay, type course, okay. And we have no TypeScript files. Course name is TypeScript. This works, but it can get wordy with many shared fields. What do you mean wordy? Like it would be duplicated? Maybe. We can eliminate the duplication by moving the shared fields onto a shared type. Okay. Course shared. Yeah, so the name is here, and that is course shared and definition parentheses. Okay. Got it. So course shared. There is started and start. Yeah, got it. Let course name TypeScript and course name. So course is that and that. So it will be type with quote type script. Here we go. I'll try some music. I think it's too loud. this raises the question of style. Should we define 4 name types, course, shared starts, unstarted courses, and cars, or should we combine them all into a single type definition? Either way works. The version of course below is completely equivalent to the one above. Ah, so cars have a name in all cases, and here begins the magic. This or that. Okay, this or that. Uh-huh. Oh, it's kind of readable. Let course name names TypeScript start at false. Plus interaction time, new date. Course name is TypeScript. Why not? Why doesn't it work? Type error? What? I guess it started false. So it cannot have the date. It's a bit hard to read. It is often better to name the pieces of a type as you build it up. Finish the lesson. Okay, error handling with unions. This is the error handling with unions lessons. We'll use a common type of JavaScript pack to explore error handling with unions. JavaScript has a number function. It converts string to numbers. It converts a number string like 1 into actual number like that. So that when we give number a string that isn't a number, it returns another number. Not a number special value in JavaScript that means not a number. Not a number is a strange name because variables of type number can hold the value not a number. If TypeScript variables of type number are allowed to hold not a number, that can lead to not a number sneak into the code where we only expected real numbers. And NaN plus anything is NaN. NaN minus anything is NaN, etc. That allows NA to flow through a system with an eventual error happening far from the original source of the bug. Or worse, the NaN might make it all the way into the database. Function square. Okay, so this is NaN. Let's write safe number, a safer version of number conversion function that doesn't return NaN. We could make safe number throw an exception when we try to convert a string that isn't a valid number. However, that's generally a bad idea for conversion function like safe number. When converting strings that come from users, we have to expect failure and handle it gracefully. Instead of throwing an exception, we can return union. One side of the union indicates success. We converted a string to a number. The other side represents failure. The string wasn't actually a number. Convention succeed, kind succeed, value number, kind failure, reason string. Okay. Type conversion result, conversion succeed, conversion failed. And we have a safe number, takes string, and results conversion result. There's a number, is not a number, return kind failure, number converted to NEN, return kind success value, and okay. It converts it automatically then. Okay, safe number, one. Oh, return, it will be kind success value 1. Safe number. This is not a number. Okay, so it will be kind failure, and value will be this is now it will be not value, it will be reason, and number converted to NaN. Now we see the C. Now we can see why our safe number is safe. It returns an object, and objects can't be added to numbers. If we try to do safe number plus safe number of some string plus 1, it will be a type error. Type error. The converted number is in the value property of the returned object. However, that value property only exists on the success side of conversion result union. Doing safe numbers some string value is a type error. Okay. The type system knows that safe number might return a failure which has no value. So this is type error. To get the number out, we force to check whether the conversion succeed or fail. Counts converted safe number, converted kind succeeds, converted value, and it is converted value or undefined. Okay, so this will be 5. Not a number, this will be undefined. This works because ternary conditional acting out. No. That those is not converted is conversion succeeds, so it must have value attribute. By returning a union from safe number, we forced callers to deal with the error case. In the ternary above, we return undefined if safe number fails. In a full application, we might show that wasn't a valid number error instead. The one thing that we can't do is accidentally continue on without handling the error. The type system guarantees that we won't make that mistake. Okay, ta-da! And we are done. Done. It's better than perfect. Currently we are 96%. That's cool. Bye.